Okay, so first we're going to talk about this example. It's about a circle. And imagine a circle is, it's not rigid, it's expandable, and that it's getting, bigger or smaller. The question asks to find the rate of change of the area of a circle with respect to its radius r. Okay, so a couple of things here. First of all, rate of change, now that's just derivative. Okay, with respect to its radius r, when we have with respect to, it means in the end the equation that you come up with, or the expression that you come up with, is going to have r in there. Okay, or is allowed to have r in there. All right, so what you start with is the quantity that is changing. So in this case, what is it that is changing? What is changing? Well, the what of the circle? The area of the circle. All right, so that's what we're going to start with. Now, we know that the area of a circle has a formula, pi r squared. Okay, now if you want the rate of change, that's the derivative. So what you want is a prime of r. Okay, now in the formula that I've written in red, pi r squared, you basically have two elements in there. You have the pi and the r. Of those, which is a variable? Pi or r? R. A variable means something that is changing, right? R is the one that is changing. R is the variable. So then what is pi if it's not a variable? It's a what? It's a constant. So whether I have pi r squared, or 2r squared, or 4r squared, or the square root of 3r squared, it doesn't matter. Pi is just a constant. So now a prime of r, the 2 is going to move down. So it's going to be 2 times pi times r to the power of what? 1. And that's it. That's the derivative. That's the rate of change.
Okay, it's 2 minus
okay?
1.
Right. Now, so that's a prime of r. You may also write it as dA. Remember how we dA, well, but dA dr, okay, is equal to 2 pi r. So when you have dA dr, what does that mean? That is the rate of change of the first variable a, that is the rate of change of the area with respect to the bottom variable r. Okay? Now part B says evaluate the rate of change of a at r equals 5 and r equals 10. Okay, let's just talk about what the setup is here. You have a circle that is expanding, okay? A circle is getting bigger. The rate at which it's expanding is 2 pi r. That means it's not a constant rate. So for example, if r is small, it's expanding at a certain rate. If r is large, it's expanding at a different rate. Let's take a look at more what that means. So here is a circle, radius 5, okay, and you've got the area there which is expanding, right? The area is getting bigger, okay? So what's a prime of r? A prime of 5. It's 2 pi times 5. It's 10 pi. Okay? Now, let's take a look at a prime of 10. Okay, so that means, what does that mean? What does that mean though? What does a pi of 10 stand for in this case?
The rate of change
The rate of change of? Yeah. The rate, there you go. It's the rate of change of the area when the radius is 10. Okay? So what is that going to be? It's 2 pi times 10, 20 pi. Okay, I know the pi is sort of like abstract for some of you guys. How much is pi? 3.14. So 10 pi would be 31.4, right? Okay, so the area here is expanding at a rate of 31.4. So for example, 31.4 square inches per second. Okay? Here It's twice that. It's 61.8 square inches per second. So in this case, it's getting bigger faster. In this case, it's getting bigger at a slower rate. Okay? So depending on what the radius is, the rate at which the area is changing is changing. All right. If R is measured in inches and A is measured in square inches, what units would be appropriate for dA dr? Okay? All right, so let's see, dA dr. And this is like some of my favorite stuff because it really, for me, it solidifies what it is that I'm talking about. Okay? All right, so we want dA dr. Okay? dA is the change in area. Okay? What units are given for area? Square inches. What units are given in for R? For R? Inches. Okay. So what are the units for this then? Really? Okay, so what if it was inches squared per second? So what it is, it's inches squared per inch. Okay, we don't cancel. Okay, so dA dr, the rate of change of the area is, let's say, 5 inches square per inch. Okay, so per inch of radius, okay, the rate that is changing is 5 inches squared. Per inch of radius, the amount that is changing, the amount of area that is changing is 5 inches squared. If we're here, right, per every inch of radius, the amount of area that is changing is 25 square inches, right? So it's inches squared per inches. I know that looks a little off, but we're gonna have to get used to it. It's just unfamiliar, okay? All right, so that's one thing that could change and we could apply a derivative. Motion, like I said before, is by far the one area where like it just lends itself to rate of change. And remember what I was saying last week is when Newton was coming up with his principles of physics, how is like speed and how are speed and time related, velocity and time, distance and time. He didn't have a way to express any of that, so he invented calculus. So you know, so it's a very natural way to express this stuff. He did. Well, he and Leibniz simultaneously, independently of each other, invented calculus, and then it was like, who got it published first? Newton sort of won. It was like a. It was sort of like marketing sort of. Anyways, he just got known first.
Are there people still that do like stuff like that today, like still like page on math stuff?
Mm-hmm. Yeah. Like every year there is a Nobel Prize, right, for new math and physics and all that stuff. Okay, so let's take a look here. Okay, so suppose that an object is moving along a coordinate line. All right, so let's just suppose there is an axis. We call it an S-axis. We could call it whatever we want, X, Y. Who said it's always X, right? This is the S-axis, and an object is moving back and forth here. Okay. Now, suppose you know the position as a function of time t. So position is going to be S of t. All right. So at t equals 0, it's here. Let's say at t equals 1, it's here. At t equals 2, it's here. At t equals 3, it may have turned around and came, it came back. But we know the position, it's S of t. Okay. Displacement, okay, is how much total distance was covered. So basically, displacement is how far away from your starting point are you when everything is over and done with? So for example, and I know some of you guys are taking physics, but let's say you start here and you're going to move along the line. So you move this way, and then you move back this way, and then you move back that way, and then you stop. So I started right there. I went quite a few steps back and forth, right? But my displacement is only from here to here, because net, compared to the very beginning to the very end, how much of a different position do you have? So it's S of T2 minus S of T1, the final distance minus the initial distance.
So if you started on the place and ended in the same place, the displacement
It's
would be 0.
correct. The distance would be infinitely, it could be whatever, yeah, okay? All right, so that's displacement. So this is from T1 to T2, right? Okay, average velocity, now, it's the displacement over the time, okay? So how much total distance did I cover? Divided by the total time, all right? So it's S of T2, T1 minus T2, and so on. Oh, this should be T2 minus T1 here. There's a typo. This is T2 and T1. It has to be consistent, okay? Questions? So if the position is given to you as S of T, then it's S of blah, blah, blah. If the position was given to you as P of T, then it would be P of T2 minus P of T1. If the displacement was given to you as F of T, then it would be F of T2 minus F of T1 over T2 minus T1, all right? So whatever the function is, the average rate of change is just that, okay? All right, so that's your average velocity. Your instantaneous velocity is just your velocity at a specific point, okay? All right, to get instantaneous velocity, it's just S prime of T. So please, 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 if anything, memorize this. Why can't I write here? Memorize this and this. Memorize and know the difference of these two, and anytime you hear instantaneous velocity, you just take a derivative, just like we did up here. Anytime you hear average velocity, you have to do F of T2 minus F of T1 over T2 minus T1, okay? These are like free points. Don't lose points, okay? So this one, you just take a derivative. Okay, so that's velocity. Well, what about speed? Speed is just the absolute value of the velocity. Okay? Why? Why is that? Why is speed the absolute value of the... It's a scalar. Absolute value has a sign, plus or minus, signifying the direction. Okay, the velocity has a sign, plus or minus, signifying the direction. Speed is just how many steps you walked, regardless of direction. Okay, so you have distance, position. You take a derivative, you find velocity or speed. Now from that, if you want to take acceleration, so from the displacement, you took a derivative and found velocity. You take another derivative and that gives you the acceleration. Okay, so acceleration is the derivative of the velocity with respect to time. So if velocity is ds dt, then acceleration is the second derivative. All right, so one more time. You have S of t. Okay, that's your position. V of t is S prime of t. A of t is V prime of t, which is S double prime of t. Any questions? All right, so if you have the position, you just take a second derivative and you find the acceleration. Okay? All right, so this is super important. How do you know if something is speeding up or slowing down? All right? Okay, when the velocity and the acceleration have the same sign, it's speeding up. Plain and simple. Okay? Positive, positive, negative, negative. I'm like trying to contain myself to not go too much into the physics, but I'm just going to stick here. Okay, when the velocity and the acceleration have opposite signs, it's slowing down. Okay. Here, when you talk about sign, please, when you have to explain it, don't say the velocity is going right, the acceleration is going. Don't say that in terms of direction. Just stick to signs. Okay? Velocity and acceleration are both positive. Velocity and acceleration are both negative. Velocity is positive. Don't bring right and left in there, because then it gets iffy. All right? Because right is not always the positive direction. What if it's going up? What if it's going diagonally? What if somebody is being a rebel and they called left the positive direction? So let's not do arbitrary like left and right stuff. Plus or minus is totally cool. Okay, dynamite blast. Okay. So a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height of S of t equals that many feet after t seconds. Okay, you're going to see 16t squared everywhere. What's acceleration due to gravity in meters per second squared? Meters per second squared? 9.8 meters per second squared. When you're talking about, so that shows up everywhere. And then when we go to feet, which I don't know why anybody does, but the books love to do it, the 9.8 then gets switched to 16. So you're going to see it everywhere. Okay? Huh?
No, it's okay.
Okay, so this is the position, right? So now we're not going horizontally, we're going vertically up and down, right? So this is the position. This is the height of the rock. So I can very easily, like if I wanted to, at t equals 5, I could plug 5 in there and figure out how high it is, right? Okay. Now, so this says, how high does the rock go? Okay. So basically, like you have this launcher, it launches the rock up, and then eventually it's going to turn back down, right? So it's going to go up, and then it's going to come back down. As it's moving up, what is happening as the position is increasing, as it's moving up, what is happening to it? Okay, so so the velocity, it's got positive velocity because it's going in the positive direction. And then it's got negative velocity because it's going in the negative direction. I'm not talking about speed, I'm talking about velocity. So the velocity is positive because it's going in the positive direction. And then when it's coming down in the negative direction, the velocity is negative. So there is one point here then, there is one instant, one split nanosecond where the velocity is how much?
Zero.
The velocity is 0.
This is like from last year.
Okay.
Projectile.
That's exactly what it is. That's actually free
Projectile
fall.
motion, projectile.
Yeah,
Free fall.
free fall.
Free fall. That's why I don't do it. This is like the simplest problem though.
I love physics.
Okay, so now so now that's, if I figure out, okay, so now I know that up there the velocity is 0. If I figure out how many seconds it took for the velocity to become 0, okay, let's say it was 0 at 5 seconds. I can take that, plug it into S, and get the position at that time, okay? So what we're going to do is this. We're going to find the time when V of t is equal to 0. Okay, so find the time when the velocity is equal to 0. Do I have v of t? No, I don't. What do I have?
You have the thing.
I have s of t. Well, what is v of t when I have s of t? It's s prime of t.
Whoa.
Okay? When you have the position, you just take a derivative and you find velocity. Okay? So, what is v of t then? 160 minus 32t, says Lauren. What do we think? I agree too. Okay? So now, we want to know the time when the velocity was equal to 0. So 0 equals 160 minus 32t. Okay? And this we can solve, right? So like 32t is equal to 160. T is equal to 5. Okay? So, it reached the top at t equals 5. Yeah, yes, it's because we're defining seconds.
We're throwing 5 seconds.
Well, this isn't the final answer yet, so t equals 5 is good, but know that it's in seconds. So at t equals 5, it was here. Okay? Now, where is here? Well, that is that's what the s of t is gonna tell me. So s of 5 is the position at t equals 5.
160 times 5 minus 60.
Correct. So s of 5, okay, is equal to 160 times 5 minus 16, 5 squared. So this is the position at t equals 5 feet, because in the problem it says that it's feet per second. So s of 5 is equal to 400, so it's 400 feet. So it went up 400 feet.
Where did the 160 minus 32 come from? Did you do the derivative?
That's the derivative. So what I'm given is s of t. And then I've discovered that I need to set v of t equal to 0. Well, where the heck do I find v of t? It's just the derivative of s of t.
It's always going to be like that.
It's always going to be like that as long as, that's what Newton said. Okay? So it's always going to be like that. V is always s of t. So now, so the rock was launched, it went up and it went down. How much did that entire process take then? How many seconds? 10. 10, right? Because 5 seconds for it to go up and 5 seconds for it to go down. Huh? Well, we always neglect air resistance. Anyway, a rock would have negligible air resistance anyway. Okay. What is the velocity and the speed of the rock? So velocity and speed, how are they similar? How are they different? Velocity and speed.
Velocity equals speed after the derivative of speed.
Not the derivative.
S prime.
Yeah.
Velocity is speed over time.
No. Yeah.
It's like kind of the same, but velocity and how it's
Right. So speed is just the absolute value of velocity. Speed is I'm traveling at 32 meters per second. Velocity is I'm traveling at 32 meters per second north.
More.
So velocity is a vector and speed is a scalar.
That too. Awesome. Okay. All right. So what is the velocity and the speed of the rock when it is 256 feet above the ground on the way up? And how about on the way down? Okay. So 256 feet above the ground. So when the rock is 256 feet above the ground, so we just said here that it went up 400 feet, right? Okay. When it's at like 256, which is right here, when it's going up and it's at 256, what's its speed and velocity? And then what about on its way down when it hits that point again? What's its velocity? So first I want to know, at what time did it reach 256? Okay, so when was the rock the rock, at 256 feet. In other words, when was S of t equal to 256? When was S of t equal to 256? Talk it out, okay? It'll become clearer, okay? All right, so S of t is 160t minus 16t squared. Let's see when that was equal to 256. Okay? All right, so first of all, can I just, there are too many 16s here. Can I divide the whole thing by 16? Why not? Okay, so 10t minus t squared is equal to how much? What's 16 squared? So now, look at that, a quadratic equation. So I move everything to the same side and set it equal to 0. Now, can I factor this? So 10 minus 8, I'm sorry, t minus 8, t minus 2. So at t equals 2, t equals 8. Does it make sense that it was there twice?
Yeah, because it went up and down.
It went up and down.
Of course.
I moved it to the other side. Where is it? Here. I moved t squared to the other side and 10t to the other side.
Oh, you moved it to that side.
Yeah. So look, at t equals 2, it was at 256. And then t equals 3, 4, 5, 6, 7, 8. It was back here. So do you see how, like, we could totally map this thing out now? T equals 5, it was there. So t equals 1, 2, 3, 4, 5, 6, 7, 8, and then 10 is back down. Okay, so now, we lost sight of what we were looking for. What is it that we were looking for? The velocity and the speed. So, on the way up.
Now we can plug it into the V, right?
Yes, we can.
And we already know it because it's like the final.
On the way up, we want v of 2, which is equal to what? What was our velocity? 160 minus 32t. So 160 minus 32 times 2. So v of 2 is equal to
160 minus
96
yeah.
feet per second. This is the velocity. Okay, on the way down. It's v of what? 8, and then I'm just going to give you the answer. It's how much? What do you think? Well, I'll let you guys do it. Negative 96 feet per second. That's the velocity. So look at that. On the way up, it's positive 96. On the way down, it's negative 96. Do you see the symmetry?
I do.
Okay.
It's satisfying.
What is the speed?
So do we actually need to show the second one or no?
Speed is 96 feet per second. I don't want to see the adding and the subtracting. I really don't care at this point. I'm hoping that you know how to add and subtract. So even if you just said for the first one, v of 2 is 96, v of 8 is negative 96, I'm good with that. And then the speed is 96 feet per second. So it has the same speed both ways. It's just that one has positive velocity, one has negative velocity. Like, that is so cool. Okay? Okay, what about the acceleration? What is the acceleration? Or it's v prime of t.
Oh.
Yeah. So a of t, what's v prime of t? So what was v of t?
V of 2 was 160 minus 32.
And a of t then is just,
Negative 32.
yeah, negative 32.
0
And then when you're just left with a constant, it's negative 32 feet per second squared. Yeah.
So A equals S double prime, does that make sense?
Yes, it does. That's what yeah. Here, right? Remember I wrote that here? Okay. And then there is no, like, you can take S triple prime for fun, but it doesn't physically mean anything. Okay? When does the rock hit the ground? T equals 10. T equals 10. Okay?
Usually just the initial time was 5 seconds to go halfway at that.
You did say that before.
When we look for the when does the rock hit the ground, we look at it as from the bottom to when it hits the ground, right? Not from the
Correct. From the bottom to when it hits the ground. You can also, Simona, you could also have taken that 160t minus, Simona was saying you could set it equal to 0. You could also, let's say you hadn't done all that preliminary work, you could have also said S of t is equal to 0. So what is that? 160t minus 16t squared is equal to 0. Let's factor out a t. Uh, 16t. This is so cool. Right? So so t is equal to 0, and here t is equal to 10.
I think the greater one, does that make sense?
Well, okay, well, they both make sense. At t equals 0, where did the rock start from?
Bottom.
The ground. So it was at the ground once at t equals 0, and then again at t equals 10. Come on, tell me that's not cool. Like, that is so cool. Right? That's so cool. That's so cool how the math, just the math, and the physics of it are so well connected. Like, that's so harmonious. Right? Come on. That's amazing. Where else do you see that? Nowhere else. Like, nowhere. Come on. In none of the other classes do you see that. Like, nowhere.
Physics.
Except, that's what I'm saying. Just physics and math. That's it. Yeah. Huh? Yeah, right.
Why? What about in my English class and English and history class? It is the same answer. Because history is always very
Huh?
Every time physics enters my life, I think it's like I'll get calculus, but I won't get physics. Yes.
Okay,